If you were not here on Friday and don't have the package, let's get you a copy. Put your phones away, get your math out now. Phones away, math out. Let's go.
Can I get a package?
You were here. I have one.
I need it. I'll have a binder.
You left yours at home. Was anyone actually not here Friday? Zach was here. You were here. Pick stuff up. Where is it? Get it up. I don't blame you. It's on your lap. Danny. Okay. I think the only person who needs you. You left your binder at home. I have one copy and I have to make more than it takes forever to photocopy. So what I'm going to do for you, Jared, use some blank paper and a writing utensil, and you're going to do it by hand today. Don't worry, the lesson's not very long. No pencil. Okay. Well, there's some blank paper for you. No, I don't know how much you need. Take back what. Just give me back what you don't use. Okay. So this was Friday. We looked at using opposite operations. I used a bunch of we called them one-step equations, where all you had to do was one little thing to, gentlemen, all we had to do was one little thing to isolate the variable, get the thing by itself, and solve for it, figure out what its value is. The problem is, some of these were so easy, you guys struggled more with the method than you did with coming up with the right answer. Like you looked at number 3 and said it's obviously got to be -2. You looked at number 4 and said it's obviously got to be 10. How could I ever possibly hope to do the methods? So we're going to make it a little bit more difficult today, and then hopefully we can get a handle on some of these methods. These are the questions I assigned. I wanted you to do odds. There's 30 questions, and I wanted you to do the odds of them. Some of you insisted on doing all of them. Some of you did the evens. So here are the answers. I will do any questions you would like out of the homework I assigned. Here are the first 14. The ones in blue are the ones I actually wanted you to do for homework. The ones in orange are the ones that you may have done if you did more than I assigned. Or if you weren't paying attention and just did them all. Because that happens too. Comments, questions, concerns, wearies, conundrums, or consternations?
Get off your phone, Jared.
Yeah, chill.
Do we have to bring back? Hey, don't give him his phone, because if you give him the phone and he gives it to me, I take it down to the office. That was yeah, it's a fun game. If you get someone else's phone, you give it to me and take it down to the office, and then they're screwed. So Jared, nobody has any questions about the homework? Okay. There's the bottom set from that same lesson. 5, 10, and 15 are all down there. The ones in blue are the ones I assigned, yes. The ones in orange are the ones that some people did unnecessarily. Dakota. And Jordan. Yeah, sorry? Okay. Okay, so that was the first chunk. Here's the second chunk. And we had a lot of time to do them on Friday, so I just assigned them all, or all the odds. There only one. No, yeah, everything here was fair game. All the blue. Is there anything anyone would like me to do from the homework? I will. You are less than 2 weeks away from a movie day in math class.
But I'm probably not going to be here on the last day because we're allowed to just not go to school on the last day of holidays.
Well, that's a choice you've made. That is the day we're going to...
Targeted.
Nope. It's just the way I roll.
Wait, isn't it a new semester after the holidays?
No, you still have 3 weeks and then a new semester. Okay. Anybody? Comments, questions, concerns? Everyone said this is really easy to do?
It's
so easy, it's hard. Okay. Well, let's make it more difficult. Maybe the more difficult ones will be easier.
No.
Okay, so then that takes us down to the bottom of the page.
Not possible.
Correct. Correct. It is not possible.
Well, do the impossible.
You can't. Because there's no variable to solve for in that last question. And negative 2/3 is not equal to negative 4/9. 2/3 is negative 0.6 repeating. And number 30, negative 2/3 is 0.6 repeating. This is negative 0.4 repeating. They're not equal. It's not possible. There's no variables. So there's nothing anybody would like me to do. Hassan, Harsh, Jared, Danny, we're all good?
Yep, all good.
Okay, wow. Love it. Then, let's make things more interesting, shall we? We're going to skip this one. What is the difference between a yam and a TV announcer? I did not assign that on Friday. It's a fun one. We'll come back to it perhaps and do more practice with it later. Page 3, multi-step equations. Take a look at this bad boy. Here we go. So, multi-step equations. Friday we did one step. These are multi-step. Multi-step equations have two, I mean, it's anything more than one, right? Two or more operations. So you have a couple things you have to do. 2, 3, 4, 5, 6 things maybe. No, it's never that many. A couple things you have to do to get the variable by itself. So I'm going to give you the steps. I'll do a couple examples. We're going to do 5 examples. And then we'll call it a day, and you guys can play. Yes.
Going to play a movie.
No. All.
Not
Into the hand and everything. Okay, here we go.
now.
So, here are the steps, and then I'm going to demonstrate them. If you can, step 1 is collect your like terms. And if you recall from last chapter, like terms have the same letter or letters with the same exponent, or just the numbers without the letters. Okay? If you can collect them, collect them. Step 1. Step 2, we want to isolate the term with the variable by using addition or subtraction. And then we want to isolate the variable within that term by multiplying or dividing. So, before we do that, here's another way to think about exactly those options. Back in chapter 1, we talked about everyone's favorite 6-letter math word, BEDMAS. And BEDMAS is the order we do operations, and that comes from what these operations mean and the order that they were done. So we do brackets, exponents, division, multiplication, addition, subtraction, and we go left to right when we've got a bunch of stuff to do. And there's no variables. Is that hard to read?
No.
I can use a different color.
I can see it. Are you guys blind? Oh, I can't see it now.
You know what? That's okay.
What?
BEDMAS. That's the order we did stuff in when we had a bunch of numbers and no letters. When we have letters, we're going to talk about Sam and Deb.
I hate Sam and Deb.
Which is very similar to a song from the, what's the song about Sam and Diane? No? No, there's a song that references them. I never watched Cheers. I'm aware of Cheers. Cheers is just the lame prequel to Frasier. Okay, so I got BEDMAS and I got Sam Deb. This is for no variables. This is what we need to be aware of for variables. And the letters mean exactly the same thing. Are there things that we can subtract away or add away? Once that's done, are there things that we can multiply or divide away? Are there exponents that we need to undo? The answer in this unit will almost always be no.
Yay!
And then are there brackets we can get rid of? Okay, so when we have variables, this is the order we try to do to get rid of stuff. Allow me to demonstrate. Okay, example 1. I have 5x plus 3 equals 23. First, are there like terms on the same side of the equal sign that we can group? The answer, Ethan says, is no. Ethan is correct. We have no, I'm going to zoom this thing in here. We have no like terms. This one has a letter, this one does not, this one's just a number, and we cannot jump across the equal sign when we're collecting like terms. So step 1, done. Now, SamDeb. Can we do subtraction or addition to get things away from the term with the x? Yes, we can. Because I have 5x plus 3, I want to do the opposite of adding 3. What is the opposite of addition? Subtraction. And whenever I do to one side, I have to do to the other. What am I going to subtract, Ethan? You betcha. I'm going to take away the thing that we're adding so that on the left-hand side, positive 3 minus 3 cancels, leaves us with 0. So all we have on the left-hand side is going to be the 5x. On the right-hand side, we're going to have 23 minus 3. You're correct, Ethan. It's going to be 20. And now we've got one more step. The addition and subtraction has been dealt with. Are there anything that we can multiply or divide away?
You said divide really weirdly, so yeah, we can divide something.
Right now I have 5 times x. What is the opposite of multiplying by 5? Dividing by?
Numbers, 2.
What number? Thank you, Dakota. 5.
Dang it.
We want to divide by what we're multiplying by to get rid of it. You knew that, but Liam's not here to give us silly answers, so now you're giving us the silly answers? Okay. So, 5 divided by 5 is 1, leaving us with 1x. And on the right-hand side, we have to do the same thing. What's 20 divided by 5?
How do you get 5, 10, 20?
Someone said 4 back here. Thank you. 20 divided by 5 is 4. Thank you, Jared. You are a champion. Okay? So, apparently we're done. Let's check. I've got my variable by itself and it equals a singular number. Let's see if that number is correct. Here's what you do. You write out the original equation you had, but instead of the variable, we're going to put brackets there. So instead of the variable, we're going to shove a set of brackets, and we're going to take this value that we think x might be, and we're going to put it in there. If we're left with something that is mathematically true, our answer is correct. So let's do it. The 4 goes in here, and now we bedmask this thing.
Wow.
So we're going to multiply first. What's 5 times 4?
20.
20.
Yeah.
20 plus 3 is?
23.
23. So does 23 equal 23?
No.
You betcha it does.
Not.
So because this is a true statement, this answer must be true. On your chapter test, you will be asked, chapter test, on Thursday next week, you guys are going to write me a test.
Thursday?
Thursday next week, you're going to write me a test.
Oh.
Not this Thursday, next Thursday.
You give me a heart
The
attack.
day before Christmas party.
No.
Oh my God.
Test on Thursday, Christmas party Friday. Then you don't have to see me for 2 weeks.
Yay. Actually,
Thank you, Dakota. I appreciate that. Okay? So, and this is a really good check. I had some students, the really common mistake that students make all the time is just spontaneously dropping minus signs. So on their chapter test, I had students, they'd come up with an answer, they dropped a minus sign along the way, and then they did their check. And they got, you said this was, the way you said it, Ethan, was like, this is, of course, 23 equals 23. But when they did their check, the one question I'm thinking of in particular, because the minus sign wasn't there, it would be like saying that this was supposed to be minus 4. 5 times negative 4 is negative 20. Negative 20 plus 3 is negative 17. And so they wrote down that negative 17 equals 23, and they said, this is wrong, but I cannot find my mistake. They still got almost all of the available marks. They got 1 3/4 out of 2. Because even though they made they dropped the minus sign, really easy mistake. They did the check did not work, and they recognized that because the check didn't work, they screwed something up, and they said, I can't find it. But I know this answer is wrong. My check proved it. And so everything worked exactly as I wanted it to. They were able to say, I tried the math, clearly there's a mistake, the check worked to show me I've made a mistake. They still got almost all the available marks, okay? So you look at this and say, Ethan, of course 23 is equal to 23, but it might not always. Yes, Jared. Okay. Second one, let's do this example. Clearly we need to go faster, so let's go faster. I've got negative 2 plus x over 3 equals negative 4. Are there any like terms there I can group together on the same side of the equal sign?
Negative 2 and 3. Does that work technically?
This is attached to the x within the same term, so no, I cannot group it with the negative 2. There are no like terms. So, Yuvraj and the twins. Do I have anything I could add or subtract away? I heard someone say yes. Jared. I can, in fact. So if you look at what I have here, I've got negative 2 plus x over 3. How am I going to get rid of the negative 2? We're going to add 2 to both sides. Very good. We're going to do the opposite of negative 2, which is add 2, and now whatever I do to one side, I have to do to the other. You betcha, on the left-hand side, it's going to cancel out the 2. So I'm left with x over 3 equals, what is negative 4 plus 2? It is, in fact, Ethan, negative 2. Very good. And so now, okay, if I look at Sam Deb, my addition subtraction is done. Do I have anything I could multiply or divide away? Well, I'm currently dividing by 3. So if I want to get rid of the dividing by 3, what am I going to do? Multiply by what, Dakota? 3. Thank you, Dakota. I'm going to multiply by the opposite of whatever. I'm going to do the opposite operation with whatever number's down here. Okay? So we're going to write down multiplication by 3 on both sides. On the left-hand side, it cancels. X equals negative 2 times 3. You're allowed to use a calculator, but you've also got your multiplication tables. 2 times 3 is 6. And we're good. Let's check.
Yeah, you should be.
Negative 2 times 3, Denny, is negative 6.
Why don't you take your earbuds out?
Hey, Ethan.
I'm just trying to help out fellow classmates.
You're trying to help a fellow classmate out in a way that you're trying to get him in trouble.
How?
Let's do the check. Negative 2 plus bracket bracket over 3 equals negative 4. I'm going to take my value that I think x might be, and we're going to put it into that set of brackets right there. So I've got negative 2 plus 6 over 3 equals negative 4. The first thing BEDMAS says, when all I've got is numbers, the first thing I do here is brackets. Well, there's no math in the brackets. There's no exponents, multiplication, and division. What is 6 divided by 3?
1, 2, 2.
What mistake have I made here? What mistake have I made here? I arbitrarily dropped a minus sign. See, look at me modeling mistakes that you guys are going to make all the time. You actually have to make sure you plug the right value in. Thank you, Dakota. We're going to put that minus sign in here. Negative 6 divided by 3 is negative 2. So I'm going to have negative 2 plus Negative 2. Is negative 2 plus negative 2 equal to negative 4?
0. It's 2 negatives.
I meant, no, that's not how this works. I meant negative 2, and I'm adding more negatives.
But if you have
It's
a negative thing in your life, you have more negative things.
It gets more negative.
Negative.
No, it gets more negative.
The more negative it is.
No, you got, okay, don't screw around because you're messing yourself up. If I have something negative and I'm adding more negative,
you get stronger.
you get more negative. So negative 4 does in fact equal negative 4, and we're good. Take this off here. Or Garrett's desk so I can make more copies of it. See. Okay. Next example. I'm going to jump to Brown. Here we go. Step 1. Are there like terms I can group in this one?
Yes.
Yes. What are they?
7 and 2.
It's not 7 and 2.
Which one are we looking at?
Wait,
It's negative 7 and 2.
Oh.
You have to include the sign out front. It matters.
I didn't see that. If it was like my test, I would look very thoroughly at it.
I think you and I both know that's not necessarily true.
Whoa, this is why.
No, it's not true. You see a test, you panic, and you're like, you miss the minus signs. In class, you see the minus signs. So, negative 7 plus 2 is, Hazan?
9, 6.
Okay, don't just spurt out random things. We're screwing people up.
Negative 5.
Give me an honest answer.
Negative 5.
It is, in fact, negative 5.
Negative 5.
We're at negative 7, and we're going up 2. We need to stop shouting out answers that are obviously wrong.
Yeah. Well,
So I've got x over negative 2. These two gather together to give me minus 5 equals 6. And now, because I've gathered my like terms now, I can start undoing the operations that are there to get x by itself. The first thing we're going to get rid of is what? Yes, we're going to get rid of the negative 5 by doing what, Dakota?
Negative positive 5.
We're going to add 5 to both sides. Thank you, Ethan, even though I didn't call for you. That was good. So the negative 5 plus 5, we did the opposite operation here. It cancels out. Very good. And I'm going to be left with x over negative 2 equals 6 plus 5 is 11. Okay, calm yourself. You're right. I'm proud of you. Calm it down. My last step here is to do what? I've got x divided by negative 2 equals 11. Yes, I want to get rid of the division by multiplying, and I want to multiply by the same thing I'm dividing by. So we're going to multiply both sides by negative 2. On the left, they cancel. On the right, I have 11 times negative 2. 11 times negative 2 is negative 22. And we're done.
Now we gotta do the check?
Would you like me to do the check?
No, not really. It's probably right.
I was going to skip this check because I have 2 more I want to go through. I want to give you lots of time to practice this stuff. So we're going to skip this one, and we're going to go down here. Step 1, collect like terms if you have any. Are there any like terms? Yes. Ethan, give me one set of like terms.
Negative 4, negative 2.
Okay, what is, so I've got a negative 4, I've got a negative 2, negative 4 plus negative 2 is?
Negative 6.
So those are going to group together, give me negative 6. Very good. Someone else, are there any other like terms? Thank you, Garrett. Negative 3x and plus x. What is negative 3x plus x? Negative 3x plus x. If you're at negative 3 and you're going up 1x.
Negative 3x to 12.
Okay, what number is in front of the x when there's no number written? It's a 1. So you have negative 3x's. I don't know, no, it doesn't work that way. You owe me 3x's.
How do you have so many X's?
No, I don't have any. You owe me 3x's.
Oh, dang it.
and someone else gives you one. How many x's do you owe now? You're at -3, going up 1.
Negative 2x.
There you go. Now you're at -2x. When you're combining like terms, the letters and the exponents on those letters do not change. Just the number out front. -3x plus 1x is -2x. And this still equals 5. The like terms have been grouped. Now we can solve. The first thing we have to get rid of is what?
-6.
Yes, we want to get rid of the -6 by adding 6. Very good. I'm hearing the same thing from both sides of the class. It's always Dakota and Ethan.
Yeah, I'm just so happy to answer for you.
Hassan, where's your package? Harsh, where's your package? Okay, you're just using the same desk. Okay. -6 plus 6, these cancel. On the left-hand side, now I'm left with just the -2x. And on the right-hand side, I'm left with 5 plus 6 is 11. Now I want to get x by itself. Jordan. No, it was -3x plus 1x is -2x. Yes, Dakota, I want to divide by -2. So x equals 11 over -2. Now, on your students will look at this and say, my answer's a fraction, I did something wrong. Students do this all the time. That is not true. Fractions are numbers too. Don't be Mathist. This is a totally acceptable final answer. On your chapter test, there is one question that will have a fraction as its final answer, and you need to be comfortable with that. Yes, Javon, you can go do what you need to do. Okay, one more question, Ethan.
Oh, yeah.
I would like you to take this question, and I would like you to scribble it out. And I'd like you to write down the following question, Ethan.
Yo.
We're changing it. N minus 8 all over 4 equals -2.
What question was that?
Bottom right. The one on the bottom right. Is that the bottom right? Then that one. Yes. Okay, write down this question. And we're going to put a line down here. And I'm going to show you 2 different ways to handle this question. Okay. First way.
-8.
No. Just not now. Don't mess around now. I want you to see what's going to happen here. So this is very similar to some of the stuff I was giving you last chapter with the polynomial stuff. I gave you this stuff and I said, okay, do the division. What you needed to remember in the polynomials unit was that when you are dividing a polynomial by a monomial, you need to break up the polynomial in the numerator into its individual pieces and put each one over the denominator. So, Jared, Ethan, stop screwing around, please. I'm gonna rewrite this question as n over 4 minus 8 over 4 equals -2. First step. And now I want to simplify where I can. Can I divide -8 by 4? Yes. What's -8 divided by 4?
See, I'm not good at division. I leave that to someone else.
Or, okay, think about it this way. How many times does 4 go into 8? Twice. So it's going to become n over 4 minus 2 equals -2.
Oh, so it's just 2. -2.
Yes. So now, now we can get rid of some more stuff. I've got a -2 here. The opposite of subtracting by 2 is adding 2. And whatever I do to one side, I have to do to the other. -2 plus 2, gone. On the left-hand side, I have n over 4 equals. Now, this is where, another place, students screw up all the time. -2 plus 2 is 0. You actually have to put that number here. I see it all the time. Students are like, oh, the answer is 0. I'm not going to put anything there. When the number is 0, you actually have to put the 0 in there. Because now we still have to solve this thing. I've got n divided by 4 equals 0. So we're going to get rid of the divided by 4, opposite of division is? Yeah, we're going to multiply both sides by 4. On the left-hand side, it cancels. I'm left with n. What is 0 times 4? Anything times 0 is 0. So 0 times 4 is 0. This is our answer. Okay. Sorry? No, it's the same as this. This one up top here is the same as this one down here. I'm not doing it. But I am going to do this one a second way. Here's the second way to do this question. I've got n minus 8 divided by 4 equals -2. A way to handle this, instead of doing the polynomial division, if you're like, I don't want to do that, that's terrible. The other way you can do that is first, throw brackets around the numerator. So we're going to have n minus 8. We're going to put that inside of a set of brackets. All divided by 4 equals -2.
I forget this. We don't get graded.
Sort of.
So if like judges are.
Okay, no, I'm just don't take me away. Don't take me away from this. So instead of breaking this thing up and doing the division, if I look by throwing the set of brackets there, I'm going to rewrite SAMDEB up here. And we're going to go through this in order. Look at where the brackets are in SAMDEB. The brackets are at the end. So you don't touch them until you've gotten rid of everything else. Is there anything that we could add or subtract away that's not inside those brackets? That's not inside the brackets. No. There's nothing out here being added or subtracted. Is there anything outside here being multiplied or divided? Yes, Jared, there is. You're right. I have in brackets n minus 8 divided by 4. So what's the opposite operation of division? Multiplication. So what we're going to do is we're going to multiply 4 on both sides. On the left-hand side, because I'm multiplying and dividing by 4, this thing cancels before anything else happens. No, don't do that right now. I'm almost done, Jared. Just hold off the crinkly bag, finish the question with me, and then I'm done. Do not open that. Nope. On the left, I'm left with n minus 8. Because there's nothing else there, you don't have to write down the brackets. Yuvraj, are we good back there? Okay, on the right-hand side, I've got -2 times 4 is? 2 times 4 is?
8.
And make it negative. Okay. And now my last step here is, because I've gotten rid of everything else, the brackets are gone, and now I've got n minus 8. What's the opposite of subtracting 8? Adding 8. Good. Left-hand side, they cancel. N equals -8 plus 8 is?
0.
I got the same answer 2 different ways.
That's pretty cool, dude.
I thought so too. Thank you. Okay.
So we did it SAMDEB way,
We did it SAMDEB way.
and then we did it Bendax.
This was polynomial multiplication way, or polynomial division way. This is adding the brackets and looking at it like SAMDEB. I do not care which way you choose to do it.
Like on any question.
There are times where this is the easier way, and there will be times where this is the easier way. How you choose to approach it does not matter. Find a way you're comfortable with and go for it. Okay, I'm done talking. You're done listening. Here are the questions I'm going to assign. There are 30 of them. I would like you to do odds and number 16. Odds and question number 16.
Can I go on strike?
You may not go on strike.
I don't like this. I don't care.
And do I want to do an and?
No. Ethan, you should bend it.
What's that?
If you finish this, let me know. Now go for it. There you go. That's your homework. Odds up to 30. And question number 16, I'd like you to note upside down on the second page, answers, Hassan and Harsh. Bottom of the second page, answers you can use to check your work. Okay, Ethan, stop it. You have work to do on your market. That's not funny. You have work to do on your market. Say giver.